So we're going to talk about the Agile enterprise ontology, and I know that sounds a bit like an oxymoron. Any of you have been in that, but that's what we're going to talk about for a while. If you were here before the break, Michael, Malcolm, Peter, and Dennis, I think, gave a great round of presentations, essentially about why we ought to be doing this, and the time is right now, and now David has just told us what this is. So I guess in that sort of context, I'm going to say a little bit about how you do this. Now, before you go running for the exits, I'm going to be mercifully brief. This is 30 minutes. This is more pragmatic at a high level, especially not only if you are an ontologist, but especially if you're managing a bunch of ontologists. Here's some kind of lessons learned from over a decade of doing this that I think you could certainly apply to ontology, I think almost to any kind of modeling. So here's where we're going to go. I just want to give you some insights that you can use and take away that are going to do three things that I think most people secretly want to do. One is, and everybody has mentioned this, these things aren't written in stone. We're going to build these things and extend them over their life, but there are certain properties you can put in a model that make it easier to extend, and certain things that just make it brittle and hard to extend. So that's one of the first things we want to look at is what can you put in place to allow your ontology to grow? Second thing is, if you're going to let it grow, how are you going to let it grow without breaking everything that depends on it? In other words, there has to be some part of it that's stable and you can count on and people can build things on, and yet at the same time, you want it to evolve in place and things like that. And then thirdly, what we learned over the course of the last several years is that these things are kind of hard to understand. And there's certain things we can do to make them easier to understand, because if people don't understand them, they won't adopt them. If they don't adopt them, what was the point? So that's where we're going for the next half hour here. And we came to this conclusion that if these things are going to be adopted, they're going to have to be agile. However, when you throw around that agile word, especially amongst a bunch of data modelers, I guess I got ahead of myself. I'll get back to the agile problem. I'm going to tell you a little bit about our journey. We've now been doing this for 15 years. We've been doing it in pretty much every industry we can think of for a lot of large enterprises. We've built their enterprise ontologies. We've helped them apply them. We've coached them. We're a consulting firm. We've also done a lot of work in the finance industry. I do have a FIBO hat. I forgot to bring it. I earned it the honest way by pro bono sweat labor. There we go. So in the process of doing that, I'm going to talk about what we used to do and what we're currently doing, because we've evolved our practice and it's kind of a lessons learned thing here. We used to go out and build these enterprise ontologies, and we were very proud of the fact that in the course of maybe 4 to 6 months, we could build an ontology that covered a large enterprise. And we could do that with about 1,000 concepts. And when we say a concept, we're talking about classes plus properties. If it was an enterprise data model, you might think that's tables plus attributes, and you might think we'd be crazy to think you could get that done with 1,000 in total. But actually, you can, and we did, and they were complete, and you can build stuff off of them. And we were very proud of that. But we discovered that wasn't anywhere near good enough. First thing we discovered is that's hard to sell these days. You used to be able to sell that, but nowadays you tell somebody we're going to spend 4 to 6 months, a lot of money, and then you can get started doing something, they say, well, yeah, never mind. So that was our first problem. The other thing is when you paper the walls with something that has 1,000 concepts on it and ask people to buy into it, they don't and they can't. It's just too much. And the thing that frustrated us the most, we could deliver a very elegant solution, at least 10 times simpler than anything else they had, and still, people weren't getting it, weren't implementing it. This was frustrating us a lot. So that was one thread of our thinking. The other thread of our thinking is something we call GIST. And GIST is not an acronym. It just means get the gist of something. And this is not a sales pitch for GIST, because GIST is free. GIST is an upper ontology. is kind of the distillation of what we've done for the last 10 or 15 years. As we discover new things that are common about all enterprises, we just put them out there. They're free. It's a Creative Commons license. Take it, do whatever you want, as long as you attribute it. We're okay with that. So we kept feeding things into this and discovering things. And what we found early on when we were doing some of these enterprise ontologies was, we would just design things and make up classes as we found classes and add properties as we found properties. And you know how you do modeling. And when we went back and ran the reasoner, this is a little screenshot from the tool that David was talking about, Protégé. You run a reasoner and it rearranges all your classes and stuff. And we would look at it and say, oh, that's interesting. Like half of the classes we came up with, this is just the top of a tree of maybe 500 classes, but the top of the tree, maybe half of the classes were gist. We thought, oh, that's pretty good. That's pretty interesting. So along the way, two things were happening. One, gist was evolving. As we discovered new things, we were just factoring new things into gist, and our methodology was evolving. We were changing the way we did this to where nowadays when we design things, we find that for the most part, without even trying, this is a project we just did very recently. I just ran it through the reasoner and looked at it and scratched my head and went, wow, you would probably not be able to tell that that's an ontology for product specifications and catalogs and the like, because almost none of it boiled up to the top. They're all, everything that's special about this ontology is derived and at some lower level of detail. So that whole activity is going on. We're kind of rethinking how we're doing this, and our clients are telling us they want, less investment up front, something you can understand, et cetera. They want Agile, but there's a dark side to Agile. And I think many of you guys have experienced it. When an Agile project starts, they just increment on whatever problem they're solving. They just increment. And the net result, I was talking about this yesterday, we've created an amazing number of silos in all our collective systems over the last several decades. And unfortunately, very often, an Agile project will just create its own silo. You just get started and you burrow in. So there is absolutely a dark side of Agile. And what we're trying to do now is say, how can we take the best of the Agile intention without getting sidetracked into that, burrowed in? Because what we think is that people secretly want to incrementally get to a more integrated place. So if the goal is not to agilely zero in on and solve the immediate business problem, even though that causes you to be siloed, if what you want to do is agilely get integrated, then we can use an Agile approach and start really rethinking how we're going about this. So that's what we're meaning when we're saying Agile here. So we then changed our pitch a bit about a year ago and started saying, let's build you an enterprise ontology in 7 weeks. So less upfront investment, and of course, it's by its nature a smaller ontology. But what we want it to be is both complete and implementable. So you want something in 7 weeks that covers your enterprise, and you can take it to implementation, which sounds sort of crazy, but and then how to prove that out is do something with it, build something, and in some relatively Agile-like period of time, 6 to 12 weeks, it obviously depends on what it is you're building, how long this is going to take, and extend that in some specific area, perhaps evolve the enterprise ontology a little bit, but a lot of what I'm going to talk about here is how to build that enterprise ontology in such a way that you're going to minimize the amount of refactoring you do when you actually put it to use. So that's the goal. And then there's very light slides here, but the idea is every time you use this and reuse it, you both extend the ontology and also the architecture you're building around. The whole idea is to get better and better at your internal ability to deliver semantically driven systems. So that's the premise, what we learned. One of the first things we have shifted is our methodology has gone. There's probably 3 or 4 ways you can do this, and we're also experimenting with another way, but I don't think it's going to be very productive. There's some bottom-up ways of designing ontologies where you harvest lots and lots of metadata from your existing systems. But the difficulty we've seen with that is you have a really strong temptation to go into agreement with all those distinctions all those application builders have built. They just, they make stuff up, and then you surface it, and then it looks pretty good, and you think, I should put this in ontology. And I think that just confuses, adds a lot of extra time. What we had been doing, which was pretty good, was we would have these facilitated sessions down there in the lower left-hand corner with subject matter experts and attempt to get as many people with as many diverse opinions in the room simultaneously, lots of whiteboarding and capturing and putting in, you can't see that, into a graphical tool, into Protege over there on the right-hand side, error checking, inference, model, review, come back, et cetera. Pretty classic kind of facilitated design review, which is pretty good. But what we're moving to is something that we think is more directed and gets us to a better solution more rapidly. I call it postulate and test, which is that in pretty much any domain, relatively quickly, you can create some postulates of things that must be true in this domain and construct a model around that, then harvest not only metadata, but especially harvest data and begin putting that into your system and saying, if that's true, then these things should line up this way, and just sort of test your hypothesis. So build enough of a model, harvest some data, turn it into triples, and test what you're discovering as you go. So that's one, just sort of thought for how to change the paradigm. Probably one of the biggest changes we've made is this idea of reducing cognitive load. So cognitive load is how much do you have to know to agree. And it's really, what are the number of things that you have to know in order to be competent in this new domain, in this case, in the ontology? How much are we forcing someone to know? How much of that do you have to agree with? That's even harder than knowing. And then, what of those are shared? One of the great things about an ontology is you don't have to agree with every single concept that we put into an ontology. If I create an ontology that is constructed from 3 or 4 other, or if I create a class that is constructed from 3 or 4 other concepts that you've already agreed to, if I say, for instance, that a customer is a person who's placed an order, I realize that's not a very good definition, and if you've already agreed on what a person is and what an order is, you agree on what a customer is. You may not like that label. That may be a crappy label, but you at least agree that is a concept. And so some of this is how to build up sets of concepts from things that people have already agreed to. One of the other things in semantics and in ontologies, we can construct formal definitions of classes, like I just suggested, that are pretty much bulletproof, but and therefore others will agree if they agreed with the primitives that you built them out of. But there's very little you can do on a comparable side with properties. The properties are those arcs in the subject predicate object. They're the equivalent of an attribute in a relational database. And with 1 or 2 tiny exceptions, once you invent and create a new property and put it in your ontology, everybody has to learn it. They have to learn it if they're going to use it. So of all the places to economize, economizing on properties is probably the best place. It's also kind of amazing if you come from a relational background, one of the systems I just looked at that we're replacing had something like 700 tables and 7,000 attributes. That's not unusual. You almost always have way more attributes than you have tables in a relational system. But very often in these kinds of systems, you have fewer attributes than you do tables, because we're just reusing properties over and over again. And the more you reuse them and the fewer you use, the less cognitive load on the people that have to use it. So, if you go out and look, we've done some work with a company called Global IDs who have a very interesting product that will go out and find all of your existing applications, read all your metadata, and read all your actual data, profile it, and come back and say, how many attributes do you have? And one of their clients that we're talking with now, after doing that exercise, discovered that they had 50 million attributes in production in systems with multiple users and all that kind of stuff, like it was Mike said earlier. We're not talking about spreadsheets, we're talking about real multi-user supported systems. And there's no way in the world anybody understands what those 50 million attributes are. There are just not enough people in that whole organization. Yeah?
How are you counting attributes to get so you don't need columns?
Yeah, columns of tables. They had 35,000 applications, and in total they found, it was completely unbelievable to me, because I usually talk about millions of attributes, which is a lot, but they have tens of millions. Yeah, it's kind of amazing. And what's unfortunate about that is almost every single one of those was an arbitrary design decision for some local optimization, or it was a package you bought. Most packages already have hundreds of thousands of attributes. So this is the area where vigilance really pays off. If we can economize here, you can make real benefits. So, this is where we target in an ontology to get down. There's not a lot more than a few hundred distinctions you really need to make at this level. One of the other things we've been doing lately is something we call the sketch. We have a placemat that we can, 11 by 17 sheet of paper, and the idea is to get the essential bit of the ontology on one piece of paper so people can just sit at it and look at it and draw on it and sort of get it. Obviously, there are more classes than will fit on an 11.5 by 17 sheet of paper, but it's a mental exercise to force you to say what are the most important classes and the most important properties that you want people to agree on. This one happens to be healthcare, in 30 or 40 key assumptions there. So if we're going to be agile, we need to have some way of detecting errors. Because one of the great things that Agile added to development was that very rapid error checking. Because if you're going to make it easy to change, you better make it self-checking as you go. And so we need to be adopting a lot of those kind of practices ourselves. Two of the ones that I think help a lot in this process, help speed up the error checking and help make yourself safe from your own kinds of mistakes. In an ontology, you can declare that two classes are disjoint, which means they cannot have any members in common. And it just seems like an interesting philosophical thing to suggest at some level. But as David was saying earlier, we have these reasoners. You can take your design, put it in a reasoner, and run it, and it will detect a whole category of errors that you've introduced, detecting them in a way that a traditional design wouldn't detect. However, if you study this a lot, almost all the error detection at this level is because you've introduced disjoint assertions somewhere. Because until the reasoner knows that these two things can't overlap, it doesn't have enough information. It just says, oh yeah, maybe a person could actually be a member of the class of doorstops or whatever it is. You're not gonna find that distinction. So probably the easiest thing to do, rather than throwing in hundreds or thousands of disjointness assertions, is very high in your ontology at some of the more top-level classes. Just introduce the idea that people cannot be geographic regions. I know some people don't move a lot, but no people are actually geographic regions, And if you then say that comedians are people and cities are regions, which seems sort of reasonable, and then later we come up with a Chevy Chase, we know it's not the same Chevy Chase that we have over there in Maryland. It's a city in Maryland for people who aren't from around here. But it's that kind of error checking. But if you didn't have the disjointness, it would never find those kinds of errors. And it finds errors in your real data, and it finds errors in your design data. One of the other things that I think is really pretty cool, we use the W3C standard language for querying these triple stores is called Sparkle. It has a sort of a superficial resemblance to SQL, but it's really describing what part of a graph do you want to see at any point in time. But they also have a part of Sparkle that doesn't return any results, it just returns true or false. And so you can construct queries that are just checks. And this one, you can check things at the individual data level. This one, we have a time card system. We're consultants, so we eat our own dog food. We implemented it in a triple store. And in this case, it just checks to make sure that every time you fill out your time card, the end date and time isn't before the start date and time. But you can also construct these things to check things in your design as you're designing it in the ontology itself. But one of the keys, I think, to understanding is something I call fractal modeling. It's an analogy. We do not use fractal math here or anything like that. But the idea is these fractal shapes, what makes them beautiful, what makes a fern beautiful is this sort of self-similarity at different scale. And in this case, we're looking for which things really define the major shape of your ontology, and then which things just kind of refine things around the edges. Because it's this, if you can keep the central core stable and then just make variations around the edges, most people are going to be depending on the shape of the central core. They're not so dependent on the things around the edges. So I want to talk a little bit about the kinds of things you can do to separate the core from the edge, if you will. People talk a lot about taxonomies, as taxonomies being hierarchical organization of, concepts. Most people, in my opinion, misuse taxonomies by making them giant single hierarchical trees to try and define everything. Everyone invokes Carl Linnaeus and the Tree of Life, or Melvin Dewey and the Dewey Decimal System, both of which I think are misguided. I think most taxonomies, firstly, are better off if they're split into little tiny categorizations that can stand alone. But even better, we are tempted to keep putting taxonomies in our ontologies. And I'm going to suggest, as you start to build your ontology, if you find yourself building a subclass tree, just stop yourself and ask yourself, what are you actually doing? You're introducing classes, yes, you think there's some distinction there, but if you don't have the formal definition of what the distinction is, then you may be fooling yourself. And if you do have the formal distinction of what the difference is, then you don't need to do that. Take it on faith for that for just a minute. And there's a lot of people who are interested and more than willing to debate and organize and talk about taxonomies. And we suggest if you can take the taxonomies out of your class structure and put them somewhere where you can manage them more like data, more like people have been used to managing, treat your taxonomies as data, it'll amazingly simplify your ontology. When we do this, one of the things you're going to find in an ontology is there's very often what we call special individuals. An individual in an ontology is like an instance, but in most databases, one row is no more special than any other row. There's just rows of data all over the place in databases. But every once in a while, in ontology, there's some individual that's special. Like in this case, if you ever built an accounting system and thought about it, we have accounts payable and accounts receivable. But the only thing that's really different about accounts payable and accounts receivable is who you are. It's the same obligation. If I owe you money and it would seem like receivable to you and payable to me. But so in almost every ontology, somewhere you define with individuals, because the individuals that are you, or either you personally, or you, your organization, or you, a small set of organizations that you kind of collectively call you, is some special individuals. And also, sometimes you just can't avoid using an individual, a piece of data, to define a class, just because, one of my most classics is the difference between exempt and non-exempt. We might be able to fool ourselves if we think we could come up with an ontological distinction between an exempt and a non-exempt employee, but I've tried. It's way too hard. Better to just say, that's a taxonomic distinction, and I can attach it to a class. I can actually define the class of people who are going to be salaried and who's eligible for overtime based on whether they're categorized by that tag, and I'm done with it. So if you follow some of these things, and if you want some inspiration, and there's two interesting and pretty large ontologies, just completely representative ones. One's called GeoNames. It's just out there. It's in the public domain, where there's about 10 million references to places and populations and altitudes and rivers and all kinds of stuff. And yet, they have 19 classes, and they, I think, correctly have moved most of their taxonomic distinctions to something they call features. So for them, the difference between a river, stream, estuary, all that kind of stuff, they say, that's just a feature difference. We're not going to attempt, just argue it out. And if you want to add a creek or crick or whatever you want to call it, fine. But just put it over there, and then you have 646. It's not going to change anything. Whereas SNOMED, big ontology in the medical arena, went the other route. They have 303,000 classes. And they must have a lot of ontologists. Only 152 properties, though. That's that incredibly underscores what I was talking about earlier. You don't really need very many properties, but all their hierarchy and taxonomy and everything else is in the class structure. So amazingly complex place not to go. Finally, I want to talk about an interesting recent development. This one's just coming through the W3C standardization process, and it is changing the way I'm thinking about things, which is always a good thing. And even though it's not standardized yet, you may not want to adopt it. I think you want to think about it because I think it will change the way you think. We want to have meaning in OWL and structure, what structure there is, in this thing called RDF shapes. That's this new standard that's just coming along. And I got to tell you, for the longest time, we tried to do both in OWL. If you find yourself, quote, putting properties on classes because you believe that somehow somebody's going to consume this ontology, then you've fallen into that trap, because those ones that you put on there that aren't part of the definition of the class are sort of a hint at the application that you're trying to build, and that's not the right place for it. And the ontology should be for coining new terms, saying what things mean, give you the basis for inference, all those kinds of things, not talk about structure. This is an example of what an RDF shape looks like. It's a real simple, it's like a little card, and you say my product reference, and you just say some things about it. What's interesting, and I know it looks a little redundant to what the definition is, but think about this for a second. The semantic web standards were built for open data. They're built for stuff that you're harvesting off the web, and you can't validate it, you can't constrain it, it's just going to be anything. But in your enterprise, you want a nice little curated set. You actually, for every employee in the employee roster, you want to be sure there's a certain pieces of information. And what this is doing is saying we're going to put a filter on some of our repositories, not necessarily on all of them. We're going to put this shape thing, and everything that comes into this repository is going to adhere to this. It's got some cardinality checks. It's got several things you can check. We're experimenting with taking this and automatically generating constraints, potentially automatically generating simplistic user interfaces. So here's my summary. We think it's necessary, and fortunately it's also possible. It's nice when it's both necessary and possible, to do this, to build an ontology, an enterprise ontology in a relatively short amount of time in a way that's stable, you can evolve it in place, begin using it in a relatively short amount of time. People get a lot more confidence when you do that. There's a lot of techniques that can aid you in doing that. You know, we're going to suggest moving from discovery to postulation. We're going to suggest, you know, simple is the right answer. I didn't talk much about modularization because I had to shrink this talk from a longer talk to this shorter one. You need to test, modularize, keep the structure out. And I think that's it for me.
Thank you, David.